This session is about uniprocessor and multiprocessor system. As I have said earlier, the uniprocessor system has single CPU which is present and only one task can be performed at a time, and multiprocessor is capable of performing multiple tasks at the same time. And this is the uniprocessor architecture, which consists of a single CPU with a combination of registers, PCs, ALU, etc., and which is connected to a bus through the main memory and IO devices. And this is the architecture of multiprocessor system, which is having processor 1, processor 2 and processor N. There are multiple processors present in the system, which is connected to the memory and IO devices with the help of bus, and each processor is having its own individual registers and caches, memories, ALUs, etc. This is the definition of uniprocessor. A uniprocessor system is based on single computing unit, in which subsequently a unit is capable of performing one operation at a time. A multiprocessor system is based on multiple computing units, in which parallel computation is applicable in multiprocessor system, in which if a system is performing in multiprocessor, a large program can be executed parallelly in simultaneously in different processors by splitting and dividing it equally in between the processor, and finally the output can be combined for attaining the result of that program. This is the main advantage of multiprocessor. And there are two categories of multiprocessor system, that is symmetric multiprocessing and asymmetric multiprocessing. Symmetric multiprocessing is nothing but, in this, all these processors are treated equally. If for example, if 10 systems are present in the system in a multiprocessor unit, all those 10 processor will be dividing the work equally, and each and every will be processor will work on its individual task, and finally all this output will be combined together for generating the final result. But in asymmetric multiprocessor, all these processors are not treated equally. In this, the master-slave relationship or boss-worker relationship is followed, whereas one processor is assigned as a master or boss processor, which treats all other processors within the system as a slave or worker processor. That one processor is responsible for assigning tasks to the all other processor which is present in that system. Apart from assigning the task and monitoring the other processor working, it doesn't execute any other task within that processor. That the workload is not equally shared in asymmetric multiprocessing system. Let us see the architectural diagram. This is the architectural diagram for symmetric multiprocessing system. As I have said earlier, the n number of processes are connected to the system bus, and in this, all the task will be as individual task will be shared by all those n processes, and finally the output will be retrieved. Whereas this is the asymmetric multiprocessing system. In this asymmetric multiprocessing system, there is an master processor or boss processor which is present on the top of it, and it is responsible for assigning works to the all other slave processor which is present in the system. Thus, the master processor, apart from assigning tasks to the slave processor, it doesn't do any work. Thus, its major task or role in that system is just assigning and monitoring the workload. In this, the major advantages in symmetric multiprocessing system, the tasks are equally shared, but comparatively, if task is shared between the processes and one processor completes a task within a less clock cycle, it will be idle throughout the other time, whereas other processor might be overloaded with many works. That scenario will be overcome by this asymmetric multiprocessing system, because a master processor is continuously monitoring the working of the slave processor. In such a way, if a processor is overwhelmed with more workloads and other few processes are in idle state, that work will be shared among these idle processes. This is known as load balancing or load sharing, which is applicable in this asymmetric multiprocessing system. But this is not available in symmetric multiprocessing system. The way in which the monitoring system is not available in symmetric is the disadvantage compared to asymmetric multiprocessing system. So in this asymmetric multiprocessing system, since there is a monitoring authority, the work is getting shared and the efficiency of the processor will be increased. That's it. These are the two classifications of multiprocessor systems.